Let's go through equals 3,399, smallest substring with identical characters. It gives us a binary string S and a number of ops. So we can flip the character at most number of times. So we need to find the length of the longest substring, and then we want to minimize the longest substring, which all of the characters are identical, retain the minimal length. So, for example, example one, right? We 0, 0, 0, 1. If we don't flip, the longest is 5, but we can flip one time. So we flip the middle one, right? And it will return 2. And the second one, we can flip the first or third 0 to 1, or second or fourth to be 1, right? So it will have length to be 1. And the last one, we cannot flip anyone, right? Operation, so we don't need, so the longest is 1. So we'll see the n range is 10 to the power 5 for this kind of range, right? So we can think about n log n approach. Normally, 10 to the power 6 is linear, as the power 5 is asking for some n log n. So for n log n, right, there is either priority queue or binary search, right? So let's think about if there is any look at this question. If there is any monotonic features or properties of some of the data, we can go to the binary search research approach, right? So let's look at this kind of the feature. For example, we have a string 110, 111, 0, 0, 0, 0, 0, right? So if we are able to flip number of times to be, for example, we can flip the longest one to be, we want to minimize this one. For example, we can minimize this to 4, right? That means, of course, we can set those kind of longest to 5 is also achievable, right? But if, for example, 3, no matter how many times we flip, we cannot get the smallest to 3. Then we cannot achieve 2, right? That means those kind of results have some monotonic features. That means at some point, the longest we can minimize those kind of longest to be some point, and for this kind of number approach, and all of if we are able to retrieve this kind of length, all of the lengths greater than this length is achievable. And if we are at some point we are not able to achieve, for example, 2, then 1 we cannot achieve, right? So the result is some kind of monotonic feature. So by this kind of feature, characteristic, we can think about using binary search, right? So we binary search on the result. The result we'll see the minimal of the longest length, the result of substring, right? So we'll see we binary search in a range that is 1 to n, right? Why it is 1, right? Because this string is not empty. So there will always exist in those kind of longest substring will always exist, right? So it will not be 0, so it will be 1. And if we don't do any flip, the worst case, for example, they are all consecutive zeros or consecutive ones, that is n, right? So we just binary search in the range 1 to n, okay? So let's write some pseudocode for binary search. First, character array equals s which array, and we're going to have int n equals array dot length, and int start equals to 1 and equals n, right? So we'll say, wow, this is start. While this start is smaller, start plus 1 is smaller than end, Then we're going to have int mid equals start plus and minus start divided by 2, right? So if it's achievable for this kind of mid length, right? We can use this valid array, and in this kind of num operations mid. That means it's still possible we can get smaller. So we are going to search in the left part. Then we'll say else. We'll have if it's not achievable, we should get this greater. So we'll have start plus mid, right? So in the end, we'll say because we want smallest. So if it's valid uh, array num of start, then we return start, and otherwise we return and we write a help function is valid. So means this is achievable. So for this kind of how can we tell whether for this operations number of flips this kind of longest short longest substring can be shot as the target. So what we do is that we look at those kind of binary strings for S, right? For example, we have this. And for example, 0, 0. And what we do is that, for example, this target is 3, right? So we can look at this kind of second. We can look at actually this kind of binary string are separate in segments. So these 3, because our target is 3, so that means we don't need to flip anything, right? And then we go to the next segment. This is consecutive ones, right? You will see this is 3, so we can flip this, flip this one to be 0, right? And then we look at the next part, this part. Because this is more than 3, right? So we need to flip 1. But flip 1, if we flip the last one, what happened? It will add 1 more to the next segment, right? So can we, so the things that in this case, for the next segment, it is affected by the previous result, right? So can we instead of add the last one to the next, can we do flip? For example, we flip instead of the last one, we just flip the next to last one, right? And the result is still this kind of length divided by target plus 1, right? The number of flips. And so this one we flip, for example, flip here, right? To 0, right? So we count, we need a flip 1, 2, 3, 3 times, right? So so the thing is that we know if this target, right, for this kind of, we just how many flips will be the for every length, right? L1 divided by target plus 1, L2 divided by target plus 1, and sum those up. Right? But the thing is that if the target has a length 1, for example, we have 1, 1, 0, 0, 1, 1, right? So this one, for this one, right? Of course, and we know this kind of has more than target plus 1, right? We can flip the next to the last. This one will be 0, right? But for these 2 consecutive zeros, it will have some problem, right? Because if we flip this, it will add 1 to the next segment. But if we flip this, it will add to a previous segment. So either way will not be correct. So how can we handle target equals 1, right? So actually, for target equals 1, that means the length of a consecutive will no more than 1. That means those kind of substrings can be 0, 1, 0, 1, 0, 1, this kind of format, right? Or 0, 1, 0, right? So that means um, this kind of flipped result can only be two kind of scenarios, right? So we just compare this kind of subarray, this array with difference with this and this, and find the minimal. That is the number of flips. So we can write code for this. Int a equals array dot length and flips equals to 0, right? So what we do is that if target equals 0, and what we do is that for int I equals to 0, I is smaller than n I plus plus, right? So if array I minus 0 doesn't equal to I mod 2, right? So this is for the case, then we have flips, we count the flips. This is for 0, 1, 0, 1, right? Then we have flips to the increase by 1, right? So here, there is another case that is done equal to I multiply to I plus 1 multiplied by 2, those kind of things, right? So actually for the other one, we can just use n minus these kind of flips. So that what flips be mass dot mean flips in n minus flips. So this is for target equals to 1, right? For the other case, we just use count those kind of segments, then divide by target plus 1. So we'll have inter count, right? So be 0. We are counting for every so how can we count 1, 1, 1, 0, 0, 0, right? So we find that if the next is different, means we're staying at the end of this segment, or if at n minus 1, we're setting at this the end of the segment, right? So what we do is that for int I equals to 0, I smaller than n, I plus plus. So every time we should count increase by 1. So if I equals n minus 1, or not array I doesn't equal to array I plus 1, then we'll have flips equals to count should plus equal to count divided by target plus 1, right? We should have set this count equal to 0. And in the end, for these two cases, right, the target equals to 0 or equals to 1 or greater, not 0, 1, right, or greater than 1, just return flips to the great small equal than num-ops. And Python code is very similar. Just write Python code. And we should define is valid, right? So the num-ops, this is an int, and the target, this is int, return and boolean, boolean. So what we do is that that means for this many times operations, whether we can get the minimum of the longest to be target, right? So what it is that we have n flips equals length of S and flips equal to 0, right? So if we target equals to 1, then we're going to have for I in range, and we're going to have if int Si done equal to I mod 2, then we're going to flips should plus equal to 1, right? And flips equals mean flips and n minus flips, right? So if the target equals to 1, then we have else that is we're going to count the segment consecutive binary, for example, zeros or consecutive ones, right? For I in range n, we're going to have count to the plus equal to 1. And if I equals n minus 1 or s down equal to s I plus 1, right? So we are at the end of this segment, we have flips the plus equal to count and target plus 1, target plus 1. And we'll set this count equal to 0. And for this help function, we just need to return flips should small equal to none ops. Main function is that we're going to have n equals length as well. So we can put this outside actually. And we'll have start and equals to the 1 and n, right? So let's say while start plus 1 smaller than n. We'll have mid equals start plus n divided by 2, right? So let's say if is valid num-ops mid, then we can search on the left. We'll have and equals mid. Then let's say else I have start equals mid. So what we do is that we check if we is valid num-ops start. We just return start. Otherwise, just return and okay. So the time complexity will be n log n time complexity. We don't have actual space, right? Or we'll say this kind of array. It's just for easy to operation. Or yeah.